Hi, this is Lakshmikant Tiwari. In this lesson, I am going to teach about the logistic regression with the Python in machine learning. I have made a few more videos previously. If you have not watched those videos, please go ahead and visit my channel KGP Talkie. And there you can see here I have already made a linear regression, data visualization with the pandas, interactive data visualization in Python with the plotly and the cufflink, complete Seaborn crash course, matplotlib, numpy and pandas. Okay, so in this lesson I'll be first talking about the logistic regression and linear regression and its differences, and then the sigmoid function are a logistic function, and then I'll be loading a Titanic dataset, and then I'll be doing a little bit more data understanding into a Titanic dataset. Then we will be doing age groupings, and we will be understanding a survival rate as per the age and the sex, etc. And then finally we will be handling the null values into the data sets, such as null values present into the age, embarked and the deck, etc. And then finally we will be replacing or imputing age and the embark, etc. And after that we will be doing a little bit the conversion of categorical data into the numerical data, so that we can prepare our data set for final model building and the training. In the final stage of this video lectures, we will be building a logistic regression model, and our model will be achieving 82.71% of the total accuracy. Okay, so let's do not waste time. Let's go ahead and start this lesson. Logistic regression is a classification algorithm used to assign observations to discrete set of classes, unlike to the linear regression. In a linear regressions, we were providing a continuous observations, but in the logistic regression, there is just a discrete observation, 0 or 1. That's when the true or a false. Some of the examples of the classification problems are such as email spam or not spam, online transactions is fraud or not a fraud, tumor is malignant or just waning. Logistic regression transform its output using the logistic sigmoid function to return its probability value. And as you see here, this is a logistic sigmoid function. Okay, so on this we apply our algorithms on this line, and accordingly it predicts whether it is 1 or the 0, and we can assume that here at a 0.5 is a baseline. If probability is greater than 0.5, then it will predict 1, and if probability is less than 0.5, then it will predict it 0. Right? So the logistic regression is a machine learning algorithm which is used for a classification problem. It is a predictive analysis algorithm and based on the concept of the probability. Such as you can also apply it into the rain forecasting, such as whether the today rain will take place or not. But if you want to measure the amount of the rain, then you need to apply a linear regression. That's when the how much rain, how many centimeter it is going to rain today, right? And if you just want to know whether it is going to rain today or not, then you need to apply the logistic regression. We can call logistic regression a linear regression model, but a logistic regression uses a more complex cost function, and this cost function can be defined as a sigmoid function, or also it is known as a logistic function instead of just a linear function, unlike this linear regression. The hypothesis of this logistic regression tends it to limit the cost functions between the 0 and the 1. Therefore, the linear function fails to represent it as it can have a value greater than 1 or less than 0. That's mean in the logistic regression it can never have a value greater than 1 or less than 0. It is a kind of the impossible as per the hypothesis of a logistic regression. Now the question comes, what is the sigmoid function? So the sigmoid functions, you can see here a function of a sigmoid function is equal to 1 upon 1 plus e power minus z. No matter what is the value of this z, the value of this sigma z will be always in between 0 and 1. if z is 0, if z is 0, then the value would be 0.5, and if z is infinite, right? If you see here the z is infinite, then you will see here the value of this e power minus infinite would be the 0, and in that case the value would be the 1. But if z is minus infinite, and in case of the minus infinite, in case of the minus infinite, if z is minus infinite, then overall the value would be the plus infinite, and the plus infinite would be the infinite. 1 upon infinite would be around the 0. That means the overall the value could be only in between 0 and 1 according to this function. Okay, perfect. Now let's go ahead and understand the decision boundaries, how we make a decision as per this decision boundaries. Let's suppose that there is a classifier is given, and a set of the inputs are given there, okay, x1 and the x2, and based on this set we need to draw a line which can classify, in fact classify these two sets, and which can actually draw a line, classification line, to classify these two different sets, right? So this is the regression line, actually the regression line which is classifying these two sets, these two different sets, okay? And in this lesson we will be taking the Titanic example. The Titanic was a British passenger liner that sank in the North Atlantic Ocean in early morning hours of 15 April 1912 after it collided with an iceberg during its maiden voyage from Southampton to New York City. So there were so many people who had died in this the tragedy. There were around 2,224 passengers and crew aboard the ship, and more than 1,500 people died on this crash. Okay, it has been almost the 100 year, more than 100 year to this crash, but for the machine learning beginners this is the perfect example to begin with the logistic regression. So in these examples we will be predicting how many people on the given set of the age, the class of the passenger, sex, etc., whether the person is going to survive or not. So we'll be training on around 80% of the data our logistic regression model, and after that on the 20% of the data we will be the testing our model, and we will be testing its accuracy. Okay, perfect. Let's go ahead and build a model which can predict if a passenger is gonna survive or not. So we need to first load some package into Jupyter Notebook. So we are going to load first traditional packages such as NumPy, Pandas, Seaborn, and Matplotlib. So let's go ahead, import NumPy as NP, import Pandas as PD, import Seaborn as SNS, and import matplotlib.pyplot as PLT, and then matplotlib inline. Okay, now let's go ahead and import logistic regression from sklearn.linear model, import logistic regression. Okay, perfect. It says that they cannot import a logistic the regression, actually yes, it's a logistic regression. Okay, now we are going to first load a Titanic data set. So here we have the Titanic is equal to SNS dot load dataset, and in this we are going to load Titanic. Okay, so let's go ahead and see its head, the head of the Titanic dataset. So in the Titanic dataset we have a head. These are the columns and these are the given to us, such as survive, passenger class, whether person is survived or not. So this survive will be our the target class, and here it's a passenger class, sex, whether person is male or female, and there is age, and if there is siblings present in the ship or not, and here is the parents and the children, and there is a fare, and here embarked, that is their cabin embarked, whether they have they have boarded to the ship from whether the Southamptons or somewhere else, and here they have a class, and then it's a kind of the sex and the who. Okay, so we can neglect this who, and whether the adult male is adult male, that's when if person is aged more than 18 years, and there is a deck name. Okay, and then embarked town, so S for Southampton and C for Cherbourg, and there are few others, we will see those. Let's say if we can see those. Yeah, Q is Queenstown. Okay, so there are 3 cities from where person has boarded. Person have boarded the ship from Southampton, Cherbourg and Queenstown, and this one says that whether the person is alive or not in the today's date, and this one says that whether person was traveling alone or not. Okay, so now let's go ahead and understand this data in a little bit more detail. So you can do that with the Titanic dot describe. Oops. So with this we can see here there are 891 entries present into this data set, and if you see there are but 714 entries are present into the age, and with this we can say that the age is missing. Okay, so there are for a few people the age is missing. That means we need to do some data engineering as well in this data set. So in this lesson we will be doing those data engineering further. Now let's go ahead and understand this data. Okay, so with this what I'm gonna do here, I'm gonna just write here data understanding. Okay, perfect. So here we have a Titanic is null dot sum. So it says that there are 177 people. The age is missing from 177 people, and the deck is missing for 688 people. Embarked town is missing for 2, and of course embarked is also missing for the 2. So what we can do, we can fill this age as well as we can fill this embarked town, and we can drop this column. Since there are so many values are missing in this column, so it's always advisable that if the data is missing more than the 50%, then we can safely discard those column. So now let's go ahead and see it with the heat map into using a seaborne. If you don't know how to plot a seaborne heat map, then you can go ahead and see my previous tutorials on a complete seaborne crash course. Now let's go ahead and see SNS dot heat map, and then here we can see here the Titanic is null, and then of course is null, and then we are going to set here the C bar. Okay, I'll show you what are these things first. So you see here the C bar is this one, okay, that's the color bar. So let's set this C bar is equal to false. Now you see here there is no color bar, and now let's see here the C map, that's the color. I'm gonna set here where it is. Now you see here with this we can see here the deck is missing a lot, but the edge, just a few edges are missing. But in the embarked there are just a few, that is exactly, to be precise, just the two. Okay, so we are going to first see how many the percentage, what is the percentage of the missing edge. So let's go ahead and see that with the Titanic edge. So with this we can get the edge for all the people, and is null. With this we are going to get here how many the null values are present there. Okay, and then we are going to set here the Titanic shape. The shape is 0, and then we are going to multiply it by 100. This says that around 19.86%, which is, to be precise, the 20%. Okay, so the 20%, for the 20% people age is missing, so we can fill these 20%. The proportion of this age missing is likely small enough for reasonable replacement with some form of imputation. Looking at the cabin column, looking at this deck column, it looks like we are just missing too much of the data to do something useful with that the basic labels. So we will probably drop this later in this tutorial. Okay, perfect. Now let's go ahead and first see the age and the distribution of the age. Okay, so with this we can understand what is the age of the people who have boarded to the ship. Okay, so let's go ahead, do some plotting with the matplotlib. If you don't know how to plot these multiple axis plots into matplotlib, then I would suggest you to go ahead and see first this matplotlib crash course tutorial. Okay, so here we need to first get access for age, the data set. So here we have a Titanic.age, then here we are going to do the histogram, that's the hist, and in this I'm gonna set here the bin size is equal to the 30, and then the density is the true, and then stacked is equal to the true, and then color is equal to, here I'm gonna set here the teal, and then here alpha is equal to 0.7, and then I'm gonna set here fixed size. The fixed size is going to be 16 and 5. Okay, so here we will get the axis for the histogram, which will plot the histogram of the age. Now I am going to plot here first. You see here, right? So this is the histogram. Now let's go ahead. I'm going to plot here the density function. Okay, so with this one, what I can do here, the Titanic and then age dot plot kind is equal to density. Okay, so here the kind is the density and color is teal, right? And then I can set here, let's go ahead and see it first. You see here, now we have got here the density as well as a histogram. Now let's go ahead and set a label. Set ax dot set x label, and then age, then plt dot show. Now you see here, this is the age and here is the density. So with this you can see here there are a number of the children. Okay, so there are many children who have boarded to the train, to the ship, and otherwise there are middle-aged people in between the 20 to 35 around. So the density of those people are high, and then there are children. Okay, so now let's go ahead and see the distribution of surviving people according to their age. Okay, so with this we can understand what is the factor of the age in surviving of the people. Okay, perfect. So now let's go ahead and first write a code for that. So here I'm going to write here survived, okay, is equal to survived, and then not survived is equal to not survived. Fake access is equal to plt dot subplots, nrows is equal to 1 and ncalls is equal to 2, and then here we have a fixed size is 10 and 4. And apart from that, let's go ahead and see how many omens are there. Okay, so the omen, the Titanic, and in that we are going to apply here a condition for a sex. So the Titanic sex, if it is a female, okay, and similarly for men, here we have the Titanic, and here sex is equal to male. So here we will get a series for men and women. Now let's go ahead and plot this. So here we get ax is equal to sns dot dist plot. In my Seaborn tutorial, I have taught their distribution plot in a Seaborn. There, let's go ahead and see here women. Okay, so here we have got this women data frame and the main data frame separately. So now let's go ahead and see here women data frame. So here we have women, and then we have here a survived. If you see here, the survived is this one. Okay, so here we have survived, and if this is equal to 1, that's mean this is survived, and if it is survived, then we are going to get here the age. In that we are going to first drop those ages which are not present, and then here we have a bins. The total number of bins I'm gonna give here the 18, and then we have here a label. Label is equal to survived. Okay, and then here we have ax is equal to the access 0. Okay, and then finally we have here the KDE plot is equal to false. Okay, so if we run this, you can see here with this age for the women, we can see here the children and somewhere between 20 and the 35 aged women have survived more as comparison to the much aged. Okay, and similarly I'm going to set here for unsurvived, for those who has not survived. Okay, so for those, what I can do, I can just copy it and paste it here, and then I can put it to the 0, and let's make its bin size to the 40. Okay, and their level, for this one level I'm gonna set here not survived. Okay, and the KD is a false for this one. And then finally I am going to set legend here. So the AX dot legend, and then AX dot set title. Then here we have a female. Okay, so if you see here, survived, almost the most of the female candidate has survived, and their age range is almost equally distributed as age is distributed here. So there is not any abnormalities in the surviving. If you see here, so this is kind of the people who has boarded on the ship, and the similar kind of the women passenger has survived. Okay, now let's go ahead and see for main candidates, for main passengers. So for this, what I need to do here, I need to do here the main, and this one is also main. Here we have a main, and here we have a main. Okay, and the axis should be here 1. Why axis 1? Because here I had created the 2 column here. Okay, so it has written the 2 axis, and now I'm going to plot this main on this second axis. Okay, now let's go ahead and see here. So if you see here, the not survived. Okay, so the male passenger, mostly the male passenger has not survived, but if you see here, the children, okay, so in female and the male as well, the children has survived. Okay, no matter whether they are male or the female. So age is also a factor in the surviving, as well as the sex is also a factor to estimate whether the person, a passenger is going to survive or not. Okay, perfect. So moreover, you can see that the men have high probability of survival when they are in between 18 and 30 years, which is also a little bit true for women, but not fully. For women, the survival chances are high between the 14 to 40 years. And for men, the probability of survival is very low between the age of 5 and the 18, but the survival is very high between for less than 5 years. Okay, and the another thing to note is that the overall survival for female passenger is high than the male passenger. Okay, so now let's go ahead. Now let's go ahead and see how many male and female passenger has boarded to the ship, and that we can get from this who. There it's written there the man or the woman. Otherwise we can also get from the sex. So let's go ahead and do a value count here. The Titanic, and there we have the sex. And there we have value counts. There you see here 577 male passengers were there, and 314 female passengers were boarded to the Titanic ship. Okay, Perfect. Now let's go ahead and see the relation between the passenger class and the age. Okay, so in this way what I can do, I can plot here a categorical plot. I can do the cat plot. There the x is equal to the P class and y is equal to age, and then the data is equal to the Titanic, and then kind is equal to box. Okay, so in this way we can see here the first class passenger, the age of the first class passenger is a little bit high, which is supported by of course the people earning. Once people ages and they they save the money, and moreover they try to the travel in a higher class. And the third class passengers are mostly youngsters, which are around 18 to 30 years. And of course it can be supported by the people in their early age have less savings. That's why they had just bought a third class ticket. So there you can see as the class of the passenger increases, there the respective age has increased. Now let's go ahead and see the fare with the passenger class. So with this what we can do, SNS dot cat plot, and there x is equal to P class, and then y is equal to fare, and then data is equal to the Titanic, and then kind is equal to box. So there you can see here in this, if you see here the first class passenger fares were pretty much high, but the third class and the second class passengers fare was pretty much low. Now let's go ahead and see the mean of the first class mean age of the first class passenger, second and the third class of the passenger. Okay, so that what we can do, for that we can do the Titanic, and then the Titanic, and then we have here the P class is equal to 1. Okay, so there we have age dot mean. Okay, so there you see the first class passengers age mean is around the 38, and similarly we can, let me copy it and paste it here, and if we set it to the 2, the second class passenger mean age is 29.87, which is roughly 30, and third class passengers mean age is around 25. Okay, so now let's go ahead and impute the missing age, that's mean fill a missing age, and with the mean of their respective passenger class. Okay, mean age of their respective passenger class. So for that I need to create a function, a method into a Python, that I can do a def age impute underscore age, then calls. Okay, there I have age is equal to calls, 0 calls. Okay, and then I have here P class is equal to call, that's the 1, and then finally here I have got the age and passenger class. Now let's go ahead and see if PD, okay, pandas data frame is null. Okay, PD dot is null, that's the age. Okay, so it says that if age is null, then what we need to do here. Okay, so if age is null, now let's go ahead and check the passenger class. If P class is equal to 1, then we need to fill it with 38, so just return here a 38. Otherwise what we can do here, we can just copy it and we can return it with that one. Okay, perfect. And apart from that, let's go ahead and check else if. So if we have elif, okay, if elif passenger class, okay, here we have elif p class is equal to the 2, then what I can do here, p class is equal to the 1 and p class is equal to the 2, there I can return here with the 2. And similarly, elif p class passenger is equal to the 3, then I can return it with the 3. Okay, otherwise I need to return just a simple age. So let's just run it and let's go ahead and apply this function to the Titanic age column. So there we have a Titanic age is equal to the Titanic. There we are going to pass here first the age, and then we are going to pass here passenger class. Once we have this one, then we can apply it with impute age and axis is equal to the 1. Okay, let's go ahead and see here a heat map. Okay, the Titanic is null. Now here a C bar is equal to false. C map is equal to where it is. Right, now you see here there is no null values into age. Okay, so all null values has been filled with the mean of their respective passenger class. Perfect. Now let's go ahead and fill this embarked. Okay, so we need to first do we need to do some analysis for that one first. Okay, let's go ahead and write here analyzing here embarked. Okay, so here we have embarked. Now we are going to analyze this embarked. For that one we need to go ahead and we are going to create here a facet grid. Okay, so for a facet grid I'm gonna just create here f sns dot facet grid, and then here we have a Titanic, then here we have a row each embarked, row is equal to embarked, and then here we have HEIJ height is equal to the 2.5. then we have to also pass here aspect ratio, that's the 3. Now let's go ahead and map on this facet grid, and there I'm gonna map here a point plot. Okay, so there I'm gonna here map a point plot, and there I'm going to add here the P class passenger class. Okay, and then I am going to on the map here the survived, as well as I am going to map here a sex, and just order I'm gonna make it false, order actually a none. Okay, and here we have a hue order, and hue order is also none. Now let's go ahead and see it here. Okay, and apart from that, let's go ahead and add the legend. So f dot add underscore legend. Okay, so in this what we see here for embarked S, C and Q, if you see here for a survived, the survival rate is for a female is high if they have boarded the train either from Southampton or Queenstown. Otherwise, if they have boarded the train from here, then the survival of the male passengers are less as comparison to the male passengers. Okay, perfect. Now let's go ahead and see for let's go ahead and fill a missing value for embarked, and let's go ahead first fill few the empty rows here. Okay, so let's go ahead and fill those missing embarked values. For that we need to do first we need to check here, sorry, embarked, sorry, dot is null, and then sum. There you can see here, sorry, oops, the two values are missing there. Okay, so what we can do, we can fill those missing values with the letters which has been embarked maximum. I mean the maximum people from which port has boarded to the ship. To know the number of people from where the people has boarded to the ship, we need to get the value count of embarked, and to do that we need to do here in Titanic and then embarked. Okay, see, you see here embarked embarked town, then dot value counts. Okay, so you see here the Southamptons. Okay, Southamptons people has boarded mostly from the Southampton, and the less from Queenstown, and 168 from Cherbourg. Okay, so let's go ahead and fill those missing values with the common value, that is S. So let's go ahead and assign here common value is S. There we have a Titanic and then embarked. Okay, so there I can say here fill any common value. Okay, and I can make here in place is equal to the true. Okay, perfect. So it says that common value okay, perfect. Now let's go ahead and check if there is any null values. It says that 0 null values. That means there is no null values present into the embarked as well as into age. So let's go ahead and see it with the heat map. So SNS heat map. There we have Titanic and is null. The Titanic is null. Oops. C bar is false. C map is viridis. Okay, so there we have here. Now what we are going to do, we are going to drop this deck column. Okay, so let's go ahead, and apart from this the deck column, instead we need to also drop the deck embarked town alive. Okay, so let's go ahead and drop those column. There we have here the Titanic dot drop and in that we are going to pass here the labels which we are going to drop here. We are going to drop here a deck, we are going to drop here embark, town, as well as we are going to drop here alive. Then we are going to put here axis is equal to 1. Okay, perfect. Now let's go ahead and see it here. Perfect. Now you can see here there is no drop column. Okay, there is no the null values into the data set. Okay, perfect. Now let's go ahead and do some feature transformation. Why we need to do the feature transformation? Let me first say show you the information. Now you can see here. Okay, why we need to do the feature transformation. Let me show you why. Let's suppose that here we have a particular set of the ages where people tend to survive more, such as children less than 5-year-old survives mostly, and the people who have aged in between 20 and 35 has survived more. Okay, so in this way what we can do, we can make some the distribution of these age to create a new feature set from this just a single the age column. Okay, so that's why we need a feature transformation. And apart from that, machine learning algorithm works on an integer or a floating value, that's in the numerical values. But if you see here, the most of the values, few values are into the categorical values. Okay, so such as the class and the sex, etc. So these values are categorical values, are embarked. We need to change these categorical values into a integer values as well are numerical values. So that's why we need to do here a feature transformation. So let's go ahead and first convert the fare, age and the passenger class into an integer type. Okay, so let's go ahead, and here you can you can see here as well the passenger class. Here the P class is 64. Otherwise, how you can see here the Titanic with the head. You see here the P class, the survived, etc., etc. These things we are going to make here the first integer. So let's go ahead, make it the integer, the Titanic, the fare. Okay, is equal to the Titanic fare, then as type, there I'm gonna set here int, and similarly here I have a Titanic, and then age is equal to the Titanic, and then here I have age dot as type. Okay, int, there I have a Titanic, P class is equal to the Titanic, P class dot has type, there I have int. Okay, perfect. Now let's go ahead and see the info on the Titanic. The first, it says that the method object is not I think here somehow I had made a mistake. Yes, yes, perfect. Now let's go ahead and see here. These are now has become passenger class, etc., etc., the integer 64. Now let's go ahead and convert these categorical data into a numerical data set. Okay, First I'm gonna insert some more rows that you can do with just by pressing a B key on your okay. Now let's go ahead. Here I am going to convert categorical data into numerical data. Okay, genders is equal to, first we need to convert male, I mean the genders are the sex. So here we have a genders male 0, okay, and the female 1. So it's kind of, I'm going to do a mapping here, the Titanic, and then here we have a sex is equal to the Titanic, sorry, dot map, map. I'm going to map this dictionary into the Titanic genders. So wherever it will find the male, it will replace that with the 0, and whenever it will find the female, it will replace that with the 1. Okay, so it says that the data frame object has no attribute map. In fact, I need to set here a sex first. Okay, that's mean I need to apply this map on a sex column. Okay, let's go ahead. Now these sex column has become 0 1 0 1. Okay, perfect. Now let's go ahead and convert the who column. Okay, so this who column, whether the man, woman, or children. Okay, if you see it here, okay, the child, okay, the age of the child would be less. Okay, see here, the child age is 2 or the 14. Okay, such as, because the surviving probability of a children is more in both male and the female passengers, that means this is also very important features to consider. So let's go ahead and consider this feature as well. And to do that, I'm gonna create a dictionary for this as well. And here we have a who, man is 0, and if it is the woman, then it's gonna put here the 1, and if it is child, then it is going to put here the 2. Then here we have a Titanic, who is equal to the Titanic, who, and then here we have a map, there we are going to map here who. Okay, and similarly we are going to map here adult as well. Okay, so here we have adult male, whether the person is adult or not. For that, if it is the true, if it is given the true, that's when we are going to replace it with 1, and if it is false, that's we are going to replace that with a 0. Okay, so there we have a Titanic, adult male is equal to the Titanic, adult male dot map, and then adult male. Okay, now let's go ahead and see if person is traveling alone or not, and for that we need to also create a dictionary. Okay, if it is true, then 1, and if it is false, then it's 0. The Titanic. Okay, there we have alone is equal to the Titanic. Now here we have alone, and Apart from that, there we have alone. Okay, here now we have a ports is equal to yes, okay, 0, and there we have a C 1, and there we have a Q a 2. Okay, the Titanic, embarked, Titanic, there we have a embarked. There I am gonna map here the ports as well. Oops, sorry. Okay, so now let's go ahead and see if we have any categorical data here. So the Titanic head, now we don't have any categorical data here. Class, the passenger class we already have. That's mean we can drop this column as well, and there's somehow we have missed this who, because I had got the error somewhere. Perhaps that is why it has happened, otherwise it could not be happened. So let's go ahead and drop the unnecessarily columns. We can do that with the Titanic dot drop. Okay, so here we have labels is equal to the labels which we are going to drop, such as C base P. Okay, I don't think we need to drop the C base P and the parents and the childs. So let's go ahead and keep the parents, childs, etc, etc. Just go ahead and drop the class and who column. Okay, and I'm gonna put here in place is equal to the true. It says that the who does not find because I had not given here access is equal to the 1. Now it has dropped. Now let's go ahead and see Titanic dataset head. Now we have got almost everything. Our data is now ready. Now let's go ahead and get our X columns. These are the X, and survived is our target. Okay, perfect. Now let's go ahead and build logistic regression model. Now our data is ready. Now let's go ahead and build a logistic regression model. Okay, so for building a logistic regression model, we need to import train test split and accuracy score from sklearn. Okay, so here we need to import from sklearn dot model selection, import train test split, and from sklearn dot metrics, import accuracy score. Okay, so here we have X is equal to Titanic dot drop then we have here survived, because survived is a target variable, so we need to get it into Y. So there we have X is equal to 1. Okay, and similarly we can get here Y is Titanic dot survived. Okay, perfect. Now let's go ahead and get our test train split. Okay, so X train and then X test, then here we have y train, we have y test as well. Let's go ahead, put here train test split. Okay, if you press shift and the double tab, you can see here the detailed documentation about train test and the split. There we need to put here x, y, and here the test split. Okay, so let's go ahead and put here the test split. That's the test size is equal to 0.33, and there I'm gonna put here a random state is equal to the 42. Now we have x train. We can get here the x train dot shape. There we have, this is the 9 columns and 596 rows into the x train. Okay, so now let's go ahead and do a model building. The model building and the training is really very easy as comparison to the data cleaning and feature selections and feature engineering, etc. So it is just a 3 line of a code. So let's go ahead and do model is equal to logistic regression. Here we have a solver. In the solver we have LBFGS, and then we have here the max iter is equal to the 200. Then here we have model dot fit. Then we have x underscore train, and then y underscore train. Okay, now let's go ahead and do y predict. Y predict is equal to model dot predict x test. See here, this is just a 3 line of code. This says that failed to converge. Okay, now let's go ahead and print a score. Okay, that's mean the accuracy matrix. So here we have x test and then y test. So you see here the score is saying that we have 82.71% accuracy, which is pretty good accuracy. You would not find this much of the accuracy anywhere. So thank you so much for watching this tutorial, and I'll be making this another part in this lesson, in which I'll be also showing you how you can do a little bit more feature engineering and grouping of different columns together, and then finally how you can get other metrics such as F1 score, recall, and the precision, as well as the ROC curve, etc. in the next lesson. So thank you so much for watching this video. Please do not forget to subscribe this channel. Bye bye. Have a nice day.